Hello, this is Utkarsh Srivastav from BS in Electronic Systems. This is my identity card. You can see Utkarsh Srivastav, and I will show you the first experiment of VTC curve, means deriving the VTC curve with the help of some components. So let's get started. So here you can see is there is a IC which is a IC 7400. Okay, the first and the second pin of this IC, this one and this one, is the input pin, and the third pin is the output. So what we are doing, we are giving the plus 5 volt to the first pin of the IC as per the circuit diagram. Let me show you. Yeah, so we will giving the input of 5 volt to first pin of the IC, and the output from the potentiometer. Here you can see the potentiometer. Basically it act like a voltage divider circuit. Here you can see at the last most point, the third pin, we will giving it the zero voltage, means ground voltage. You can see this one is the ground voltage. Okay, and the second pin, which is this one, white one, we will giving it to plus 5 volt, and the middle one, which is yellow color pin, is a variable pin, means a variable voltage pin. When we move this knob, which is present here, so the voltage is varies because of the resistance varies, then it basically changes the voltage. Okay, and what we will do, we will give this voltage output to the input of the second gate, means second NAND gate. Okay, and also the varying voltage, means this voltage, we will show this voltage on the multimeter. You can see there is a multimeter which is connected from the potentiometer, and for the getting the output of the NAND gate, what we will do, we will take a ADA-LM 1000 kit, and the using the channel 1 for the reading the values of output, which we will see in this laptop. So let me demonstrate this project. So I am connecting this ADLM. So you can see, after connecting on the multimeter, you can see, let me do 1 minute. Yeah, you can see there is a values, which is the voltage values. If I am changing this knob, so let's see what happened. So you can see, if I am moving this, you can see the voltage is varying. Let me show again. You can see, yeah, I'm moving, so you can see the voltage is going to change, right? Just like that. So now our idea is to take this voltage and give to the IC, and see, let's what happens. So here you can see, now the second voltage levels is 0.57 to 58 volt, and the output is nearly 5, right? I hope you can see the output is nearly the 4.5 volt. Okay, so what we are going to do, we are changing this voltage at this time. You can see it is 0.5 volt, means it is likely to be 0, and the work of NAND gate is take 0 input, and it will basically invert, right? Because the second input is already high, so it will invert the first one, right? So let us change the voltage and let's see. We are changing the voltage, you can see. Okay, yeah, you can see the line is going downward. That means it is now 1 minute. Yeah, you can see, as I am changing, and after some time, yeah, at 1.1 volt it is goes to the 0 volt. That means now the voltage is 1.1 volt is treated as a logic 1 for this IC, right? and the 0.55 is treated as a logic 0, and the between range between them is known as indeterminate region, right? Okay, so that's the experiment. So at final conclusion, we will get this kinds of VTC curve, right? At the 0.55 voltage, when we are giving the input, the output voltage is something like 0.425, and when we changes it from there to there, like 1.1, it will goes down and goes toward the 0. So that is the VTC curve of this NAND gate. Thank you.